Good day. On behalf of Appcito, I'd like to welcome you to today's webinar, Architecting Web-Scale Applications with Containers and Microservices. We have a very large global audience on hand today and a lot of material to cover, so let's get right to it. Let me introduce today's speakers, Janakiram, MSv, and Shashi Kiran. As an analyst and a technologist who still designs and builds production applications, Janakiram, MSv, is uniquely qualified to speak to today's topic. Johnny's currently writing about cloud computing and DevOps for Forbes.com. Previously, he was the analyst covering cloud technology for GigaOM Research and held technical and leadership positions with Amazon Web Services and Microsoft. Shashi Kiran is a 20-year veteran with a distinguished career in data center, cloud, and network infrastructure. Prior to joining Appcito, Shashi was at Cisco for 9 years, where he was worldwide head of marketing for their multi-billion-dollar data center and cloud networking technology groups. At Appcito, Shashi provides strategic leadership for marketing and business development. And with that, let me turn it over to Shashi Kiran. Shashi?
Thank you, and welcome to all. We had a fantastic response to this webinar, and I hope that you all find this information as useful as we are enjoying bringing this to you. First, this is the agenda. On behalf of Appcito, I want to start off with a bit of overview on what our company does and how we're helping change some of the new age application delivery requirements. I'm then going to transition to Janakiram. As mentioned earlier, Janakiram is a person who has hands-on experience in building web-scale cloud architectures, and he's one of the few that I'm very impressed with who can abstract these concepts to laymen who are just getting exposed to technology. In addition to covering the attributes of web-scale architectures, he will also get into containers along with a very elegant demo. And then we will have the second half of the session focus on microservices and the opportunity therein. We hope to leave some time towards the end of this session to have a live question and answer session, though I've requested our team to be on hand to help make that happen during the panel session as well. So before I get into who Appcito is and what we do, I wanted to touch upon a trend that all of us are intimately familiar with. And that trend is this incredible adoption of cloud architectures. No matter who you talk to, we see this tremendous adoption of cloud from businesses that have less than 10 employees to very large corporations like General Electric or even Capital One who are going all in into cloud. Now, the reason for cloud adoption is because of time to market. It could be because of lowering their cost structure or increasing their business competitiveness. But this trend is something that we're seeing as happening over the next several years at an exponential pace. Last week, Gartner released a report that talked about cloud services architectures, and one of the trends they pointed out to was that the highest growth over the course of 2016 would be coming in from system infrastructure services or infrastructure as a service. Software as a service is also going to get a huge amount of uptake with both traditional infrastructure as well as new age architectures adopting this as a delivery mechanism. One of the byproducts of this adoption of cloud is really touching upon all aspects of application, from design, development to delivery. And today when we look at application delivery, that is the space that we're addressing. Some of you might be thinking we have been focused on application delivery as an industry over the last decade or so. Why does this warrant something new? To understand that, let's focus on the box at the left. We are seeing a gradual evolution of traditional data centers and on-premise deployments shifting to cloud-based architectures. Addressing this space are some of the brand name traditional application delivery vendors who have been hugely successful building multi-billion-dollar corporations. Now, data centers are not going to go away anytime soon, but as the architecture shift from on-premise to public cloud as well as private and hybrid footprints, some of these traditional application delivery vendors are challenged because they don't have appliances that can be cloud native. They lack some of the self-service capabilities. And there is a boundary between the infrastructure team as well as application teams, which limits the visibility that they can provide into application behavior, analytics, and performance. This has led to the box on the right, as many companies are born in the cloud or adopt cloud-native architectures. Because traditional ADCs weren't necessarily suited for this architecture, we have had a plethora of open source tool sets, do-it-yourself toolkits, all of them pop up, and they have been very successful in establishing a massive footprint. But as these applications scale, as the manageability becomes an issue, these toolkits are also challenged. They are not necessarily conducive for operational simplicity. They provide the DevOps toolkits, but when scale or security becomes an issue, then they run into challenges. So this is the place where Appcito is fitting in. On one hand, we want to bring in a mechanism where traditional enterprise IT, which is moving applications to the cloud and having a hybrid footprint, can enable and empower their application teams to have self-service portals with complete visibility of applications across the entire spectrum to both the infrastructure and application teams, and at the same time enforce governance as well as security. So we bring the aspects of agility with visibility and control. And if organizations are directly adopting cloud native applications and going down the path of a public architecture, we are in a position to bring that management simplicity, scale, as well as visibility and security. And I'll talk a little bit about the deployment models therein as well. We're doing this through a product offering that we call as Application Delivery System, or ADS. Basically, it's comprised of 3 tenets within the product itself. One that focuses on application traffic management with elastic load balancing, traffic shaping capabilities. The second that looks at all aspects of application security, as well as analytics. So we're in a position to uniquely offer this across different deployment models. And the product offering itself is very conducive for DevOps style deployments. And it also brings in a very comprehensive management GUI as well as dashboard that allows for the flexibility of these management models. ADS is purpose-built for these new age architectures, including containers and microservices. And we look at ourselves as the industry's first self-service cloud-native application delivery system for public, private, and hybrid cloud deployments. A brief overview of the architecture itself. This is a software-defined architecture. At its basic elements, it comprises of a cloud services controller and a cloud services proxy. The controller is where the enterprise infrastructure teams or the application owners themselves can centrally provision policy. They can enable a self-services portal. They can also get access to a dashboard with the analytics on application performance and behavior. And this also becomes the management construct. The cloud services controller, in turn, orchestrates elements of the cloud services proxy. The proxy is a highly distributed system, and it front-ends the application, providing application traffic management, security, as well as analytics capabilities. As the proxy scales, it can share state, so it is very conducive for web architectures that require higher availability and distributed state awareness. And as we progress towards microservices from monolithic applications, we see this lightweight footprint of the proxy that front-ends the applications being a very elegant choice for this architecture. Now, the beauty of Appcito's offering is it offers deployment flexibility. The controller and the proxy can be hosted by Appcito, where we offer the service to our customers looking to go down the path of cloud-based applications. The controller can be in a cloud environment, where the proxy can be on-premise. or vice versa. And the other aspect that's resonating extremely well with our customers is it offers them choice. It can work over any of these clouds that you see below, whether it be Amazon Web Services, Microsoft Azure, Google Cloud Platform, or on-premise private cloud deployments that are focusing on OpenStack or VMware-based deployments as well. So for anybody looking for multi-cloud deployments as well as a SaaS-based offering, Appcito's architecture becomes extremely compelling. With that, I would like to transition over to Janakiram, where he will talk about how some of the new trends on web-scale computing are driving best practices for companies that are not necessarily web-scale. Janakiram, over to you.
Thanks, Ashi. We have been exposed to quite a few jargons, the terminology, like web-scale computing, containers, microservices, and cloud-native computing. While there is a lot of relevance and a context that brings all of them together, the web-scale computing is the architectural paradigm which is primarily motivating enterprises and even mid-sized companies to adopt some of these emerging technologies. So what exactly is web-scale computing? So this term has been prominently visible or used in the last couple of years, and it was Gartner who created this in 2014. And the whole idea is some of the well-known scalable businesses, web businesses like Google, Amazon, and Facebook, the methodologies, the paradigms, the architectural design that they use, how can that start penetrating into the enterprise data center, and how can enterprises take advantage of the architecture that was confined to traditional web-scale companies? So when we look at how enterprises can adopt and emulate the proven web-scale design and the data center patterns, what are the attributes that they should consider? So the very first thing is the infrastructure. The data center itself is purpose-built. It's not a generic traditional data center. So fundamentally, the data center is changing. It's transforming from being a very traditional infrastructure layer to a much more cohesive unit or pool of resources catering to the new age workloads. So the data center is fundamentally different between traditional enterprise IT environment versus the web scale environment. If you can recall, Google runs their data center or their infrastructure on custom-built machines standing up on Lego blocks. So while enterprises may not be looking forward to running their servers on Lego blocks, they are still looking forward to getting the same agility and the same experience of achieving the scale. And it's just not the infrastructure, even the applications need to be refactored, redesigned, and built for the new approach. And that's where we have the web-oriented, or more recently known as microservices architecture, coming in. Programmable management translates to infrastructure as code, where the entire building blocks of infrastructure, whether it is compute through hypervisor, storage through virtual SAN and virtual storage, and networking through software-defined networking, is becoming extremely programmable. And customers can take advantage of that to bring in a lot of agility. And velocity-focused processes is how they can take advantage of these new capabilities evolving out of the data center for achieving better agility. And collaborative organization style is primarily another term for DevOps. So blurring the line between the development teams and the ops team, and opening up a channel of communication and making them more collaborative is extremely essential for achieving web-scale computing. And finally, innovation-centric and learning culture is how fast can the businesses iterate through their feature set, and it primarily translates to a very efficient continuous integration and continuous deployment pipeline. So all of this looks like very well-known DevOps process or DevOps methodology. In fact, it is not very new. This has been evolving over a period of time. And what has changed is the evolution of technology. So we are currently experiencing a set of technologies that are converging to deliver web scale computing. So what are those trends? So let's focus for some time on the application architecture and its evolution. Over a period of time, the monolithic architecture is giving way to distributed architecture. So this is again not revolutionary. This has been happening over a period of time. Those of you who have been in the business of software development can recall how client server moved to distributed computing and how distributed computing went to SOA and from there to cloud. So we are on that journey of achieving the nirvana in terms of distributed computing. So this is a moving target. So distributed computing is a journey rather than a destination. And DevOps that was once confined to small and medium-sized businesses and startups has become more prevalent even in enterprises. So large businesses also understood the benefits of embracing the DevOps culture, and that is influencing quite a bit of change in the software development lifecycle. And the most important trend is development has become polyglot. Today, you cannot zero in on the J2E stack or .NET stack. You get to deal with a very diverse set of operating systems, languages, frameworks, runtimes, databases, client devices, whatnot. So it's very, very complex and very diverse when it comes to development. And despite all of this, application portability still remains a dream. It's extremely difficult to port applications developed in one environment to another. Today, we are living in a siloed world where private cloud cannot talk to the public cloud, and hybrid cloud is still a very expensive proposition to achieve. So these are some of the challenges that are hindering the adoption of web scale computing within the enterprise and the data center. So since we are talking about data center and infrastructure, let's also focus a bit on that. The most radical change that we have seen in the last 18 months is the unit of deployment changing from a server or a machine to a container. So containers are fundamentally changing the way software is designed, developed, tested, integrated, and deployed. So when the focus shifts away from a machine or a server or a virtual machine to a container, everything changes. More on this later as we discuss containers and how they are enabling enterprises to deliver web scale computing. And infrastructure has become immutable. Today, the trend is not to fix broken VMs. It's better to replace them because infrastructure and VMs have become disposable. It's far more expensive to SSH into a broken VM and trying to debug it rather than launch it from an existing golden image or an image that pulls the latest build and the config and registers itself with the load balancer. So that is far more efficient. And with containers taking over the deployment model, there is a lot of emphasis on treating the data center as a pool of resources, which is basically a cluster, and that commoditizes hardware. We have seen this happen with public cloud, where we don't ever deal with the individual machine. Now, those VMs that are running on individual machines are further getting consolidated thanks to containers. So with containers, there are new challenges to provision, orchestrate, manage, monitor, and all the new ways of dealing with application lifecycle. And that's where we are seeing technologies like Docker Swarm, Kubernetes, Mesosphere data center operating system, and Rancher OS, and some of these emerging technologies helping the ops team manage the evolving infrastructure. And finally, automation is now a much more complex job because you have to orchestrate bare metal machines, VMs that are running on top of it, the containers that are further getting abstracted, and finally the apps. And this increases a level of complexity in managing the entire lifecycle of applications. And this all leads to the bottom line, which is better TCO, right? So ultimately, you're getting more VMs per machine and more containers per VM and more apps per cluster. And that directly translates to better efficiency and better utilization. And the total cost of ownership is much more effective and realized with the new infrastructure design. So I want to talk to you about the new trend of treating the data center as a machine. So physical infrastructure doesn't go away. You still see those racks, the stacks of servers, the storage units, the networking gear, nothing changes. That is still there. And virtualization has already taken over the data center. This is also not new. But what's new is consolidating the virtual infrastructure into a homogeneous pool of machines called as logically clusters. And these clusters are the new units of runtime or new units of execution. And these clusters don't differentiate between one virtual machine or the other virtual machine. You effectively treat all the virtual machines running in your data center as one humongous, powerful, high-performance computing unit. And this computing unit can host multiple clusters, and each of these clusters will host multiple apps that are managed by the cluster manager or the orchestration. So this is the new avatar of the data center, where physical infrastructure is getting commoditized further, and VMs are also getting commoditized by cluster architecture. And there is a new layer, a management layer that is evolving, which is called the cluster manager. And this is exactly where you will use Docker Swarm or Kubernetes or Mesos or some of the evolving tools. And your applications are the new generation applications that are designed to deliver the web scale performance and web scale architecture. So at the front and center of this shift, we have containers. And if you have been in IT and if you have been remotely associated with system administration and DevOps, I'm sure you heard of containers. So they are changing the way applications are running in each of the machines or virtual machines. Think of it as lightweight virtualization without the overhead of a hypervisor and a full-blown virtual machine that's running on the physical server. So you take one server and you install the container management software, and this container management software will create multiple lightweight processes where each process lives in an illusion that it is the only process that's running. So the new container management layer is exactly like hypervisor, but it runs within the OS and is responsible for bringing strong isolation between these lightweight processes which are treated like individual machines. And at the heart of it, the underlying kernel is shared among all the processes. So you don't have the overhead of creating the operating system all over again. And since it relies on the fact that the kernel of the operating system is the same irrespective of the Linux distribution that you're running, it's extremely portable. You can develop on CentOS and deploy it on Debian, and then finally move it to Fedora, and then finally launch it on SUSE or Red Hat Enterprise Linux. So it brings in extreme portability because you assume that the lowest common denominator is the kernel that is powering the lightweight process, which is the container. So obviously, these are much faster. If a VM takes few minutes to boot, containers boot in few seconds. So that delivers extreme scale. And the name that is synonymous with containers and container management is Docker. Of course, Docker is not the only one. CoreOS has a container management layer and a container technology called Rocket, and pronounced as RKT. And Canonical has their own container called LXD, pronounced as LexD. And Microsoft is innovating with Hyper-V containers and Windows Server containers. VMware is doing vSphere containers and Photon for their environment and more aligned with vSphere. So if you look at any operating system vendor, they are very actively and very swiftly moving to the container trend, because they know that this is a very important trend that would influence their customers and their application development lifecycle. So that's a brief introduction to containers. And the number one benefit of embracing containers is the separation of concerns. We know that developers are measured on how fast they iterate to deliver features. Right? Development teams and developers and architects are rewarded for shipping more often, adding more features, being more agile, being more innovative, and customers love to see more features. But when you look at ops, they deal with exactly the other end of the spectrum. They hate changes. They are measured, they are rewarded, they are promoted on stability. But change and stability are the opposite sides of the coin. Right? It's very hard to make something stable that is changing very often. So that's the reason why most of the enterprise application development and IT were always on loggerheads, and it's very hard to bring them together and make them collaboratively work. With containers, that friction between developers and operations team completely changes. It blurs the line, because developers precisely focus on what needs to go into the container, and the ops teams will focus precisely on how to manage the external environment of the container. So they deal with logging, monitoring, configuration, and keeping the desired configuration state retained all the time. And developers can iterate multiple times because they don't break anything if they ship faster. So this convergence is delivered through containers, and this is the single most important reason why Docker has been getting so much attention, and why containers are no more just confined to cutting edge, bleeding edge startups, but even large enterprises. This is one of the fastest adopted technology across the spectrum. So taking a look at the container architecture, so we have briefly touched upon it, and I'm taking Docker as a reference architecture. So you have the core infrastructure, and then on top of it you have operating system, and this operating system can run any Linux distribution with kernel 3.1 or above, and that's the lowest common denominator. That's a prerequisite for running Docker. So on top of Docker, on top of the operating system, you have the core Docker engine, and that is responsible for negotiating with the operating system and bringing in very strong isolation between app 1, app 2, and app 3. So these apps, instead of bundling the entire operating system, they only bring along the dependencies in the form of binaries and libraries. And these units of application code plus binaries plus configuration is packaged as a container, and that can go across multiple machines. So this makes it very lightweight, and the workflow of application development and deployment significantly improves. So I have a demo where I walk you through how I start on my machine as a developer and how I take it to the production with very minimal disruption. So obviously virtual machines, there is a debate on virtual machines versus containers. So multiple guest operating systems run on single machine in case of the virtual machines, and each guest operating system brings along its virtual compute, storage, and networking layers, and hypervisor runs on the bare metal. This makes it very heavy, particularly when we are talking about web scale computing. In the context of that, imagine when you configured auto scale on AWS. I'm talking about EC2. How long does it take for an EC2 instance come up, pull the latest build from GitHub, build it on the fly, configure it, deploy it, and then register itself with the ELB, and send the first health check and announce itself and starts participating in the application traffic. This can take anywhere from 5 to 20 minutes, depending on how complex your code is and how long it takes for you to build it and configure it. So the equation changes when you switch to Microsoft Windows and .NET. Even this Windows machine running on EC2, the plain vanilla Windows machine, takes about 20 minutes. And with all the configuration and so on, it might be close to 30 minutes by the time the machine is ready to participate in the production environment. And in web scale, 30 minutes is like a light year. And that might make or break the business. So we cannot wait for the virtual machines to boot up, to register, to light up the application and start participating in the environment. We need much more faster environments, and that's precisely where containers shine. So a little bit of architecture and also how they work together. At a high level, we have three components to container architecture. The first one is the host. And the host is the actual unit, the boundary that exposes the resources in terms of compute, storage, and network. And within this host, you have the engine, the Docker daemon, which is the management layer that handles the life cycle of one container at a time. And these containers depend on predefined images. So an image is a container at rest in a read-only format. So these images, when they boot up, become containers. So think of them as the VM template and the virtual machine. Not the right analogy, but you can relate to it. So obviously, when you have multiple images, you need to store them centrally, make it accessible to all the stakeholders, and secure it. So that's where we have the registry, which is the centralized catalog or the repository or the inventory of all the images. And these images get pulled and they get pushed, they get cloned. It's very, very close to the way GitHub works. Anyone can fork technically an image and modify it, commit it, and push it back to the registry. So this is the lively, the living and growing organic repository of images. And then once the image gets pulled and gets instantiated, it turns into a container. And once the container comes up, there are client tools that talk to the container for managing them. And obviously that happens through an API endpoint exposed by the Docker daemon running on the host. And the client can run on OS X, Mac OS, Microsoft Windows, and of course Linux. So it doesn't matter whether the client is on any of these operating systems, but the Docker daemon has to run on a Linux host with certain prerequisites. So that's the high-level architecture and the big picture of Docker. Now, let's take a closer look at managing the application lifecycle with Docker and how it ties back to our web scale computing promise. So a developer starts coding on his workstation, and once he is done, once the testing is also done and it's ready to go into the staging environment, he turns the code into a Docker image. And this is a pretty straightforward process. This can be a part of the build process itself and can participate in the continuous integration and continuous deployment pipeline. I don't want to make it sound very complex, but this is an integral part of the CI/CD process. So the Docker image that is populated with the latest build goes into the registry. As we discussed earlier, the registry is the centralized catalog, which is going to be the distribution endpoint. And once it goes to the registry, it will find its way to test, staging, and production. And in production, you see multiple instances of this running. And the biggest benefit of this paradigm is the dependencies, the prerequisites, and the artifacts required for the application to run are self-contained in this executable, the unit of execution, which is the container and the container image. So that prevents the very classic syndrome of, oh, it works on my machine, which, by the way, is the most uttered sentence by most of the developers. And that syndrome vanishes when you switch to Docker and containers, because what runs on the dev machine would work exactly the same on production. So there is tremendous parity and the compatibility between environments. And it actually pays back when the developers are developing on a production environment, right? It is mimicking and emulating the production environment. And the production environment is in sync with the dev environment in terms of the prerequisites, runtimes, and what is expected. So nothing is going to break, because everything that is required by the app flows along with the app as a part of the Docker image. And this is the fundamental unit of scale, which will eventually translate into delivering the promise of web scale computing. So it's time for us to go through a demo. And a quick disclaimer, I'm not going to show you a rocket science application. My objective is to show you how containers are becoming the nucleus of web scale computing and how they are fundamentally influencing this paradigm. So I want to show you a simple app, but walk you through the entire workflow of what I have just shown you. So time for me to switch to my terminal window. So if you see, I have a bunch of JavaScript files. In fact, I'm developing a Node.js application, which looks something like this. And I have borrowed the classic, popular, well-known MVC to-do application from Backbone.js. So this is production-ready code. I can go live. And what I've done is one line of code that might be of interest to most of you is I basically check for the environment. If it is a development environment, I fall back to my local MongoDB instance. So I use localhost. If it is not development, I use a remote MongoDB connection. This ensures two things. One, I am able to separate the environment with minimal disruption, with minimal configuration. Of course, I may read this from a config file. I can discover it, but to keep it simple, I have hardwired the connection string. But in production, I might actually pull this from a service discovery endpoint or from a config file. But the idea is I have a very clear separation between how I deal with the local dev environment and how I deal with the production environment. And the second important aspect is this ensures that my app is extremely stateless, 100% stateless, which means I can very effectively scale the application without worrying about keeping the stateful data in sync, because I am isolating the statefulness from my app to a centralized service like the Mongo Lab. So that's the only interesting aspect in this app. But let me go ahead, run this, and show you how this looks. So it might be pretty familiar to most of you. So I'm running this, and it is currently listening on port 3000. So let me switch to my browser and show you. So this is localhost port 3000, and what needs to be done? Ship code, right? So that's what I want to do. So this is my dev environment running on localhost, completely powered by Backbone.js, MongoDB, and Node.js. Okay, so now this is perfect. It's working, and it's time for me to move this to my staging environment, right? So what do? I don't give a setup script or a configuration file or readme.txt. Instead, I go ahead and build my entire source code into a Docker image. And for that, I put some instructions to build my image in what is called as the Docker file. So the Docker file picks up my source code from my local repository or even the file system, and it takes the Ubuntu 14.04 LTS image as the base, copies my entire source code into a directory called src, and runs the apt-get update and the routine infrastructure code, basically to ensure that we are getting the latest version of Node.js, NPM, and the depending modules. And we are exposing port 3000. Finally, we move into the SRC directory and kick off the node process with app.js as a parameter. Pretty straightforward. But mind you, this is not a shell script. It's an instruction to Docker to build this into an image. So now that I have the Docker file in place, I can use Docker build followed by a tag, and the tag will distinguish my image from other images. So I give a unique name and I pass the current directory as the parameter. So Docker build will quickly create an image from my current source code, which is completely tested and ready to go. So to save time, I have already created that image. So, okay, let me, okay, so what I have done is I have already moved my Docker image to a local VM. So this is my local VM, which is running the Docker environment. So when I do Docker images, you notice that my to-do app is compiled into an image, built as an image, and is living in a centralized repository called que.io, which is owned by CoreOS. This could be Docker Hub, this could be your private registry, it doesn't matter, but this needs to be secure, this needs to be accessible. So once I have this image, I'm going to go ahead and push this image to the central registry, right? So when I do a Docker push, I'm basically getting my image to be deployed on multiple other environments. Again, this is going to take a while depending on the bandwidth. Remember, we have to upload about 235 MB of image, so I don't want to take a chance. So I execute this command, and then it takes us to the repository. So this is my que.io CoreOS repository, and here I have the to-do app repository, right? So this is perfect. Now we have successfully moved from a dev to staging. The VM was my staging, and I built my Docker image and pushed it to the centralized repository, and now it's available for going live, right, into production. So for production, I am on EC2. So I have two VMs running. One is prod to do 1, prod to do 2, and these are running in the very familiar EC2 environment. And now it's time for us to take our to-do application to production, right? So let's switch back to the command line. So here I have Docker running, right? And by the way, I am on EC2. So this is my EC2 instance. So I'm already running Docker version 1.9.1, the latest. And here I come back and do a Docker pull. So when I do a Docker pull, I'm essentially getting my image to my production environment. So Docker pull que.io followed by my username, and this basically downloads the entire image, which will take a few minutes depending on the bandwidth. So to save time, I have already pulled it and it is ready here. So this is our image, which has flown in from our dev environment, right, into the production. And it's time for me to run this. So if you see the Docker ps command, which will show you the running containers, I don't have any container. So what I'm going to do is run this command, which I'm going to walk you through in a second. So when I run this command, I pass -d to run the container in detached mode, and I'm exposing port 3000 of our Node.js app as port 80 of the host, and this aligns with the security group that I already created. And most importantly, I'm passing an environment variable to let the image know that this needs to run in production, which means it will now start talking to the Mongo lab instance that we have already provisioned. And this centralizes the database, and it is provisioned in Amazon, so it's sitting next to the app, and we are also ready to scale because we don't have any state. So I pass the image name. So this will now run our container. So we see that it's up and running. Port 3000 is exposed on port 80. So let's come back to the browser and refresh. So now if you notice, this is the IP address that EC2 has assigned to my instance, right? Now the magic starts, right? So it's not just one instance. I can go ahead and launch multiple instances. The only thing is I don't want to deal with 80 because that's already taken. So I'll create one more with 81. And now we are going to create the third container listening on port 82 and one more with 83, right? Now when we do docker ps, we notice that there are a bunch of containers that are running listening on different ports. So if you come back to the browser and type the appropriate port number, you would see the same. So if you type something as your to-do list and switch between ports, that would still be retained because this data is stored in MongoLab. It's completely out of the context, right? The state context. So that's the beauty of it. And as you notice, it just takes us a few seconds to scale from 1 to n number of containers, right? So I have also launched another EC2 instance, and here I'm running a dozen VMs, right? If you see from port 80 to port 91. So let me check how many I'm running with the word count command. So now we have 14 containers running in the second EC2 instance. So now imagine we have two VMs, and across these two VMs, we are running about a dozen containers listening on different ports. And this is fantastic scale, and we are very close to realizing the power of web scale. But that's not all. We still need to live with certain challenges, and that's where the other story begins. So let me switch back to my presentation and talk to you about those challenges. So when it comes to containers, you might be wondering, how do I make sure that the port number is not conflicting? How do I dynamically assign a port and still register it with the load balancer and make the container participate? That is the lingering question in your mind. The second question is, how do I load balance all of them and secure all of them? How do I manage centralized logging? How do I know which container is in healthy state, which is not? And how do I apply some of the best practices of infrastructure monitoring to containers? Well, this problem is not solved by one layer of software. So the application, the container orchestration engines like Kubernetes, Docker Swarm, Mesos, Cisco Mantle, and Rancher address certain problems, certain challenges in the new world of containers. Kubernetes handles quite a lot of them. It's one of the most mature, robust container orchestration engine. Docker Swarm is very simple yet very powerful. Mesos along with Marathon delivers a very powerful container management capabilities, and so does Cisco's open source orchestration engine called Mantle. But they have a well-defined boundary. They are primarily orchestrating the containers and handling some of the challenges of automatically bringing them up and maintaining the state across all this. And when I say state, the cluster state. And they track the health. They do a set of functions to ensure that your containers are in sync and they're delivering what they're designed for. But on top of that, we need an application delivery platform, which will help you bring in the proven bulletproof security to microservices and the high-level load balancing, that has to work across the VMs, across the containers seamlessly, and manage the entire logical handoff between the VMs and the containers. And of course, bringing in operational insights from the aggregated logs coming from these dozens of containers running on tens of VMs. and even taking it to the next level by consuming these logs and then applying machine learning to predict how they will behave in different conditions. So that's exactly where Appcito ADS, the application delivery service, comes into the play. Now, going ahead with microservices. So if you're wondering what is the correlation between containers and microservices, well, microservices is a design pattern which is independent of containers, and it's a pattern that is designed or encouraged to use smaller units known as services to participate in a larger application. So everything becomes very, very autonomous, very fine-grained, and they participate in the larger application. So this is Martin Fowler, who primarily defined and pioneered the paradigm shift to microservices. You can read more about the whole architecture on his site. So monolithic versus microservices is a classic debate. I'm not going to spend a lot of time. You can read multiple articles and opinions and point of views on this. Basically, monolithic runs as one unit, right? When you scale at the rate of one server at a time. Whereas in microservices, you don't scale at one VM at a time, but you scale one service at a time. And the service can run within one VM or across multiple VMs. So we basically look at a very flat architecture, right? And when it comes to the flat architecture, those of you who are familiar with the J2E or the Microsoft .NET architecture, we have traditionally designed systems that look like a three-tier architecture, right? So you have the user interface at the top, then the application server, and every application server running one component at a time. So the problem with this approach is when you want to scale out, you bring up another application server, but within that application server, there could be precisely one component that is extracting all the juice of the server. And while the remaining components are not really exploiting any power. So in that case, why should we run component 1 and component 2? Why can't I bring them down and load more component 3s in my system so that it can deliver the right performance without the other components hogging the memory and the processing power? Well, that is not possible in traditional monolithic three-tier architecture, because every time you scale out, you scale at the VM level. And whether you like it or not, every VM, every server comes with all the components loaded in it. And that's not the most ideal way of delivering web scale experience. So in microservices architecture, we live in a flat world. So the application server cluster becomes a pool. So all the VMs will get reduced into this layer, and you have the nodes, which are logical boundaries, and you are completely at your will to launch more components, more containers, more services, whatever you want to call them, on demand without getting burdened or constrained by VMs. So, and obviously, the connection back to containers is each of these components are now going to be delivered as containers. So these containers doing one task at a time with very well-defined endpoints are the microservices, right? So if containers are the implementation, microservices is the pattern. So the core tenets of microservices is servers are disposable, never fix them, never try to fix broken servers or VMs, spin up another. Services are autonomous and independent. And this can be thought of as the fine-grained SOA. And there is a lot of debate on whether microservices is a reincarnation of SOA or not. I don't want to get into that debate, but I personally think it's fine-grained SOA. They are loosely coupled, and they don't use synchronous communication. They are upgraded independently, one of the best advantages, and they use lightweight protocols like HTTP and AMQP to talk to each other. So coming back, connecting the dots, we started with the tenets, the attributes of web scale computing, and we are now ending with microservices. So How do microservices deliver on the promise of web scale architecture? First thing is they enable rapid scaling. We have gone from 0 to 12 in few minutes. Rapid scalability, extreme modularity. I can independently pull and push Docker images without bringing down the whole system. They are purpose built, they are autonomous, they are fine grained, they are specialized, they do one thing at a time. Better utilization of infrastructure. I pack more punch in my VMs. I run more containers per VM. So definitely it delivers better utilization. And it's polyglot. I'm not confined to using one stack, but I handpick what is best for my architecture, and I use best of the breed technologies to stitch my application together. Faster iteration. I can iterate pretty quickly because I'm not at the burden of building the whole system, but I focus on one thing at a time and iterate multiple times. So this will incrementally deliver better experience to the customers. So that's exactly how microservices fuel the web scale architecture. So I would like to hand it over to Shashi to take over and talk about how one of the customers has used Appcito for implementing microservices.
Thank you, Janakiram. That was a fantastic session. I want to just share the use case of one of our customers who is leveraging the Cloud Services Controller and proxy with Appcito service to scale their microservices deployment. Now, this customer was going down the path of open source tool sets, and he was having a really good deployment when the application instances were fairly low scale. But as he started to scale the application services and as it became increasingly distributed across data centers, that is when the operational complexity started to creep in. And then the company, which was mostly in the retail and ad servicing space, started to get exposed to issues related to security. And that's the visibility of applications became a fair bit of an issue. So this is an area where the distributed services proxy-based architecture becomes extremely compelling to front-end these microservices and scale elastically as these microservices grow. One of the patterns that we're seeing is the increase in east-west traffic, or essentially the traffic between the services, which is growing exponentially. And that's the new traffic curve pattern that we're seeing amongst customers that are looking at these type of applications instead of the traditional north-south traffic. And that architecture is where Appcito's application delivery systems becomes very compelling. You're in a position to get the application or microservice level visibility along with the ability to manage this within or across data center clusters. And this customer in particular is scaling up to almost 1 billion plus requests on a monthly basis. So this becomes very compelling when you look at sort of traditional deployments where you require multiple components for servicing each of the different functions, whether it's SSL termination, whether it's load balancing at layer 7, application auto scaling or firewalling capability. And what Appcito is in a position to do, if you look at the image on the left, is compress all of those different tiers and stacks into something very compact and yet retain all of the functions in a very distributed, scalable manner, providing that operational simplicity. So when applications start to scale in cloud native environments or when they become web scale, you want to get that degree of simplicity without compromising on security or scale. And the footprint becomes very compelling in that instance, along with a significantly reduced cost. Janakiram talked about containers. Both the Cloud Services Controller as well as the proxy are themselves available as containers and deployable in containerized environments. And they lend themselves very elegantly to microservices-based architectures. So we're having a very deep resonance of this product in the new age application architectures that we talked about, in addition to the hybrid cloud deployments. So just to summarize, we covered a lot of ground in today's session, and we hope this will be one of many that we will be sharing in the next little while. We're seeing an increasing adoption of different cloud deployments, And as clouds in the traditional monolithic data center-based approach transition to microservices and cloud-based architectures, the tenets of web-scale computing become very relevant. Regardless of the size of the company, the best practices are still something they can leverage. As we talk about, the unit of deployment is changing from VM to a container and monolithic to a microservice. And that's where application delivery system from Appcito becomes very relevant. It's been proven already in web scale deployments, and we're bringing that to traditional enterprise and IT-based organizations, which may not see that degree of scale, but they certainly find the visibility that we can provide on a per application basis, or the security and the self-service portal, all of which to be extremely compelling to delivering on that agility. It also supports the DevOps capabilities, and we look at this as being very conducive for bimodal IT or flex IT requirements. For more on Appcito and some of the solutions, feel free to follow us on any of the social media channels. We're very active on LinkedIn, Twitter, as well as Facebook. And now, for those that are looking to see how you can get your hands on it, this is an OpEx only. There's no CapEx upfront. You are free to try this for 30 days. We'll be hand-holding you as required for you to get this up and running in your proof of concept or production labs. And there's a demo up on our website as well that will give you a flavor of how quickly you can get your applications up and running in a matter of a few minutes. I would highly encourage you to watch the demo. And with that, let's open it up for question and answers. We'll handle a couple of questions. I know we're a bit over time.
All right. The first question I have is for Johnny. It's from Joe. He asks, why not eliminate VMs altogether and instead deploy containers directly on physical infrastructure?
Yeah, that's a great question. So this is something that's being debated. So some data center implementation professionals or ops professionals are evaluating bare metal directly for running containers. In fact, if you take Rackspace, they have an offering called On Metal, on which they run their container as a service called Karina, and they are experiencing a very high performance and high throughput of containerization through that. But at the same time, there's a school of thought that believes containers are best suited for VMs because there is a thin line between the VM security and the container security. So VMs obviously deliver better security, and containers they offer low level of security because ultimately they share the same operating system. So VMware, because of their business interest, and even Microsoft are heavily advocating running one container per VM, which will bring in best of both worlds. So that debate is on. We haven't reached a conclusion, but technically it's absolutely possible to run containers on bare metal physical servers, getting rid of hypervisor or even VMs completely. But we have to wait and watch how this trend will evolve.
Okay, a question for Shashi from Shane. Shane asks, can we deploy Appcito ADS on-premise, or is it only for public clouds like the AWS environment showed today?
Yeah, Shane, thank you for your question. The answer is both. Appcito originally began with public cloud deployments, where we really are in a position to deliver on cloud-native applications and web scale. As I mentioned earlier, we are in a position to do across multiple clouds, regardless of the public cloud vendor. And today, we're also helping large enterprises and financial services customers move to a hybrid cloud strategy or on-premise based private clouds as well. Appcito also supports OpenStack, but if you're looking at use cases of disaster recovery or a private to public cloud migration, you'd find Appcito's architecture to be extremely compelling.
All right. Given that we are a little bit over time, I suggest we wrap things up. We do have other questions, and we will address the additional questions individually with you offline. I want to thank everyone for attending today's webinar and for a lively Q&A. I also want to thank our speakers, Janakiram and Shashi. If you'd like to check out the products and services discussed in today's webinar, please call or visit www.appcito.com. Personalized product demos and free trials are available. Give us a call. I'd love to work with you. Thank you and have a great day.